first thing you see is the objectives of the lab. So, let's look at the objectives. You want to develop skills measuring chemicals with a graduated cylinder. You want to practice using the metric system, which we will do a unit on later. Test precision and ability to follow directions and practice lab safety procedures. But unfortunately, because of COVID, I get to just demonstrate, which I know that's really no fun, but I'm sorry. All right, so what's wrong with me right now?
You don't have goggles.
I don't have goggles on and
Your
your
hair's
hair
not tied back.
is not tied back. So one thing that I want you to get used to when you're doing a lab is checking off. As you read directions, you check off as we do each step. Why do I want you to do that?
I mean, repeat the same step twice.
So we don't repeat the same step, so we don't skip a step, we know exactly where we are, okay? So procedure part 1, it says to label 6 test tubes in order A, B, C, D, and F. I have done that, A, B, C, D, E, and F, okay? So that's already done. So you can check that. Check for part 1, number 1. All right, it says number 2, fill a beaker half full of water. Use this to rinse your graduated cylinder and test tubes. Well, I filled a beaker full of water, and I have an extra backup water since we don't have a sink in here. 3, you need a second beaker for contaminated wastewater. It's empty. This is where I'm going to pour all my wastewaters in this beaker. All right, so in number 4, where it says that 25 milliliters, change that to 21. I don't know, let's see if it'll hold 25. If it'll hold 25, we'll do 25. So it says we're going to take into test tube A, and you always double check. So if I had a lab partner, you would be checking A. Okay, so I'm going to make y'all check me, Audrey and Megan, because y'all can see. Okay? All right, measure 25 milliliters of red liquid. So I've got 3 different graduated cylinders here. This one can hold 100 milliliters. This one holds 10. This one holds 25. Think I should use this one? You are correct, okay? So I'm going to hold 25 milliliters of red liquid. Now when you measure, you don't want to be holding it up like this to measure. Because what am I doing with a graduated cylinder right now? Tilting it. I'm not going to get an accurate measure with that, okay? So I'm going to get eye level with it, where it's flat, and I can look eye level and see that I can get to 25 milliliters. So there's 25 milliliters. Now, where am I putting this?
On your waist.
Just a good example of why you don't use this to measure. Never mind. Where am I putting this?
In test tube A.
Test tube A. All right, so I've got A. Let's see if it all fit. I'm pouring it into test tube A. Yes. I've got 5 milliliters left. Change that 25 to 20 on number 4. My test tubes aren't big enough for 25 milliliters, so change that 25 to 20. All right, next step. Somebody read the next step for me. John Paul, read the next step for me.
In a test tube C, measure 17 milliliters of yellow liquid.
I'm going to measure 17 milliliters of yellow liquid into test tube C. Do I need to mix it with this?
No.
No, where should this go?
In the waist.
This is going to go in the waste. But in order to try to not contaminate, I am going to rinse. Okay? So I'm going to rinse this graduated cylinder out. Make sure I get out any red drops that are in there. Okay? And I'm going to get it all out. So I need how many milliliters of yellow?
17.
17. So I'm going to stand up here and pour it, right?
No. You're going to get eye level.
Get eye level. Alright, so. Okay, where am I pouring that?
Test tube C.
Test tube C. You see how I'm asking you to confirm that for me? I know it, but I want you to confirm it because I want to make sure I'm doing this lab properly. Alright, so we're going to pour that into test tube C. Now what should I do with my graduated cylinder?
Rinse it out.
I want to rinse it out. I'm going to take my rinse water, put it over my waste beaker. Now in the lab you would have sinks to do this. Okay. Got it rinsed? Alright, somebody read the next step. Eli, read the next step.
Into test tube E, measure 21 milliliters of blue liquid.
Alright, so we're going to shoot for 21 milliliters of blue. Alright, so we're going to get eye level again. And where am I pouring that?
In test tube E.
Test tube E. Come on, come on, come on. Alright, so now what should I do with my graduated cylinder?
Put a rinse it.
I want to rinse it. That's why I'm holding it over the beaker in case I have a spill. Alright. So we're done with part one, right?
Yes, ma'am.
Alright, so when you're measuring, you're gonna have a graduated cylinder, okay? So I've got this cylinder here. Alright, and I've got the tick marks. Now, I know that's not equally spaced or whatever, but you get the point. Alright, so I've got the tick marks in this graduated cylinder, and let's say I pour water in there. When I pour that water in there, it's not going to be a flat line of water. It's going to be kind of a curve. You're going to see it kind of curve. If you look close at anything you're measuring, you're going to see a bit of a curve. Now, it's harder to see it like a measuring cup when you're cooking, but you're going to see a bit of a curve in that water. Anybody know why?
Guys, I have is it like carrot at the moment?
Well, because it could be flat at the bottom, but water has a tendency to stick to other materials. One, it can stick to itself, or it can stick to other materials. Think about when water beads up on a car. Like if a car has a good wax job, you see water beading up on that car, and then, like, let's say it's slowly rolling down the hood, and it's one little drop, and then it gets another one, and it combines with that, and then it combines with another one to make a bigger drop. That's cohesion, where the water sticks to itself. This is going to be adhesion, where the water is sticking to its container. That curve is called a meniscus. Not like the one in your knee, but that curve is called a meniscus. And so when you read that meniscus in a graduated cylinder, you want to read the bottom of the curve. Okay? When you're reading that curve, and I'll try to walk around with it in a minute, but when you're reading that curve, you read the bottom of it, the center of the bottle. Okay? That's called a meniscus. Okay, so let's go on to part two. Alright, so it says from test tube C, measure 4 milliliters and pour into test tube D. Now that seems simple, but if you start looking at all those letters, it's easy to get mixed up. So, how many milliliters am I measuring?
4.
4. Which cylinder do you think I should use?
The smallest one.
I'm going for the smallest one, because it goes to 10. So I'm going for the smallest one, and I need 4 milliliters of what?
C.
From C. So, not from these beakers, right? No, from test tube C, I need 4 milliliters. So T is my yellow, right? Okay. So I'm gonna measure 4 milliliters. Oh, that's too much. That's too much in the test tube. That's just right. Alright, so before I into test tube D, okay? Alright, so now after I use the graduated cylinder, I want to make sure that I rinse it out. Alright, and what is step 2? John Paul, read step 2 for me.
From test tube E, measure 7 milliliters and pour into test tube D. Swirl.
Okay, so I'm gonna give from test tube E. So I've had somebody read, in my lab group, read the directions to me. I'm repeating it, so whoever read it should be listening to make sure, and watching to make sure I'm doing this right. Okay, so I've got test tube E. I'm gonna measure 7 milliliters and pour it into test tube D. All right, so I need 7. Alright, so I've got 7 milliliters, and I'm going to pour that into test tube D. You ready? Here we go. What happened?
Change color.
Change colors, okay? And then it says to swirl. So when I swirl a test tube, I'm just mixing, okay? I'm not getting violent with it. I'm just mixing. Next.
You need to rinse the graduated cylinder.
I'm gonna rinse, okay? All right, so we did step 2. Make sure you check step 2. We're done with that one. So step 3, read that for me. Eli, read that one for me.
From test tube E, measure 4 milliliters and pour it into test tube F.
All right, so we're gonna measure 4 milliliters from E. So that's my blue one. Oh, too much. Need like 1 drop. Perfect. All right, so where am I pouring that?
Test
Into
tube F.
test tube F.
Into test tube F. One drop left. All right. All right, that was step 3. What's my next step? John Paul, read 4, or Mallory, read 4 for me.
From test tube
so I'm gonna measure from test tube A, so that's my red, and I'm gonna measure 7 milliliters. There we go. And I'm going to put it into which test tube?
F.
F, and then what am I gonna do?
Swirl.
Swirl, so what do you think will happen?
And it's gonna turn indigo.
It's gonna turn into purple.
Here we go. I can see it better behind the white background, but you do have a very dark purple. And then I didn't, it mixed pretty well when I poured it in there, but it did say to swirl. That's all swirling is. Get it to mix up in there. Okay, so now I need to rinse. And we're going to step 5. So from test tube, read it for me. John Paul, you want to read this one for me?
Sorry. From test tube A, measure 8 milliliters and pour into test tube B.
Alright, so from test tube A, we want 8 milliliters, and we're going to put that into test tube B. So, just a drop. Alright, that's 8 milliliters. And we're gonna pour that into test tube B, correct?
Yes, ma'am.
Correct.
Alright, so put it into B. And I'm gonna rinse. Alright, number 6. Read that for me, Eli.
From test tube C, measure 3 milliliters and pour it into test tube B. Swirl.
Alright, so I need how many from C?
3 milliliters.
3. So not many. I need 3. Woo. I'm way over on that one. Oh, that's good. Okay. And I'm pouring it into where?
Test tube D.
Test tube B. Didn't see a whole lot of color change there.
Makes it a little lighter.
They did make it a little lighter. One drop hanging on. There we go. Made it a little bit lighter. You can, maybe a little. Alright. So we swirl it. Alright, so right now I want you to go through step 7 says save your result, measure the contents of each test tube, and record how many milliliters were found in each test tube. So first let's look at the color of liquid. What color is this in A?
Red.
That is red. What about in B?
Orangey red.
An orangish red. C?
Yellow.
Yellow.
Yellow. D?
Green.
E,
Blue.
blue. What about F?
Dark purple.
Very dark purple. Okay, so now we have to go through and measure how many milliliters are left in each test tube. Okay, so I'm worried, I don't know if some of these might go over 10 milliliters or not. Let's see. If it does, I guess we can add it together, can't we? All right, so let's start with A. All right, so in A, you've got,
It should be 10.
six point eight. I've got 6.8 milliliters left in A. Okay, so I'm gonna pour that out. Gonna rinse my graduated cylinder. All right, so now I need to measure in test tube B. All right, so that's 10 plus, hold on, I still got a little bit, that counts. It's not much, but it counts, I've got to measure it. Plus 1, so that's 11. All right, so let's measure C. Let me go ahead and grab the bigger one for C, D, E, and F. All right, C, here we go. That also has, C, I said was also 11, right?
Yes, ma'am.
Okay, so we're gonna rinse. All right, now we're gonna go to D. D is going to be 10.5. No, no. Yes, 10.5. Oh, now that water's getting nasty looking.
That was 400 degrees.
Dry. All right, E, the blue is going to be, golly, all these are really close. The blue is going to be 11.5. 11.5. All right, we're gonna pour that in our wastewater. We're gonna stop with this waste beaker.
Good idea.
last, we're gonna get F. And we're sitting right at 10 on F. Right at 10. Okay, so let's look at what you have. We're gonna go from, hey, do you have a what? I thought I couldn't see it. All right, since I'm not working with the equipment anymore, I'm gonna take off the goggles. I got my lines right here. Yeah, that's okay. All right, so how many milliliters did you have in A?
6.8.
6.8. B?
11.
C?
11.
D?
10.5.
E?
11.5.
And F?
10.
Okay, so I just put the point zeros there to hold my place. So I'm gonna add those up the old fashioned way. 5 plus 5 plus 8 is
13.
18. 1 plus 6 is 7, 8, 9, 10. 0, carry the 1. 1, 2, 3, 4, 5, 6. So I've got a total of 60.8 milliliters. That is my total. Okay? Alright, so that's the front. Now we've got our data. That's the data we've collected. Now turn over to the back and let's analyze the data. Let's answer the questions. All right, what color did we create? What
Black.
colors did we create?
Orange, green, and
Red,
purple.
yellow,
We created orange, green, and purple. Or that orangish reddish color, green, and purple. We created orange, green, and purple. Okay? Alright, so how many milliliters were in the each test tube at the start of the lab? By start of the lab, I want you to start with part 2. How many were in each test tube at the beginning of part 2? And when I say each test tube, I want to talk about A, B, C, D, E, and F, all of them. So how many were in A?
25 milliliters.
We were going to do 25, we wouldn't hold it, so we put how many?
20.
20. What about B?
0.
0. C?
Uh,
17. What about D?
0.
0. E?
21.
21. And F?
0.
0. Okay? Those zeros count. You want to record that. Even though it's 0 and there was nothing in there, we want that in our data because we want to record everything. So we want that in our data. Number 3. I'm going to let you answer that one. I'm not writing it up here because everybody might have a little bit different interpretation. But why is it important to follow directions exactly? Let's talk about it first before you answer. Why do you, Mallory? Totally mess up the experiment. And in an experiment like this, if I mess up an early step, what's happening to all the rest of my steps?
You want to get the same,
Results. Conclusion. Results. One step early on in this experiment could mess up the entire rest of it. If I poured out the wrong test tube too many times, I might not have enough liquid for the step when I needed it later. Or I would get wrong results or run out of materials. Lots of different things of, what if it was explosive chemicals and I didn't follow
You
it?
get hurt yourself.
You have if I didn't follow directions exactly, I might have a blow up. So answer number 3. Number 4, what would have happened if your measurements were not correct?
The results would be
The results would have been different, could have been wrong.
You will run out of materials.
I might have ran out of materials. There's lots of different possibilities. All right, it says, look at your hands. Do you have any stains on your hands? If so, these stains represent chemicals that would be on your skin right now. Well, you can omit number 5 because you didn't do the lab, but I do not have, actually I did have some yellow right there on my hand. Other than that, I don't have any stains on my hands. So what do I need to do next time I do lab?
wash.
I could wear gloves.
Be more careful.
I need to be more careful, okay? I haven't told you what kind of chemical this is yet. I'll tell you at the end. All right. So how many total milliliters did you have at the end of the lab?
60.8.
60.8.
I had 60.8 at the end of the lab. How many should I have had?
60. What are like pretty high stains on your hands?
Just get that one. How many should I have at the end?
22.
Where'd you get 22 from?
I added up the liquids at the beginning and then I took away how much you poured in each test tube.
Okay. Y'all agree with him? Disagree with him? Don't know?
I don't know.
So those liquids we poured out, John Paul, we just got rid of them?
I would still have them.
Oh, we still have them. We had 60.8. How many should we have?
96.
96. No?
97.
What was your thinking on that though? Maybe your thinking can help trigger us to figure out how many we should have.
I added like
What numbers did you add up?
the stuff that you move.
Okay.
I added up the normal amounts that we started off with and then added into the amounts that we manually employed to the.
Okay. Audrey's got it. Say that again, Audrey. Where did you get 58 from? She added these 3 because that's what we started with, right? We started with A, C, and E. That's what we ended up starting with.
Okay, so
Did any of the directions say get rid of that?
I came up with the completion of, well, not completion, but I came up with 58, but then I took stuff away from it.
You did, then you took stuff away, so you put an extra step in there. So that's what we need to do is add 20 plus 17 plus 21, and that gives us that we should have had 58. But Ms. Brock's measuring and lab skills were off a little bit somehow. How did we end up with more than what we started with?
our measuring wasn't precise.
Okay, my measuring, this is number 7, my measuring could have been bad. Although I tried to make sure it was right. Okay? One, maybe I didn't follow directions, okay? So, but I think I followed directions pretty well. Y'all were giving me the directions. Human error, if you didn't follow directions or if you messed up the measurement, that would be human error. Mallory, what else? when I rinsed out the tubes, I could have had some of the water from the rinse water end up staying in this and getting mixed in. And that's probably why you have more, I have more than what I started with. Now, sometimes you have less than what you started with. Some people have less. Why would they have less?
Maybe they spilled some.
They may have spilled some,
They didn't use enough.
maybe not have used enough to start with, or just like you gain some of the rinse water, you might not empty it out completely, so you might lose some if you're not emptying out your color water completely. Any questions? No questions? All right, so before I let you do your conclusion, I want to tell you what chemical you're working with. You are working, or I was working, I'm sorry, I wish you were working, with dihydrogen monoxide. So, can anybody tell me what dihydrogen monoxide? Anybody know anything about dihydrogen monoxide?
I don't know what hydrogen is.
You know what hydrogen is, okay? We know it's a liquid at room temperature.
Where's the dye?
Where's the what?
The dye. Is that like a prefix?
Oh, di is a prefix. What does it mean? Oh, multiple, a number.
Maybe it's like,
Two. Two.
oh, water. H2O.
Oxygen is O. What does mono mean?
Multiple. Mean one.
One. Mono means one.
That was
So H. it's
So
water.
you were I was working with some dihydrogen monoxide. So go home today, tell your mom you want a nice cold drink of dihydrogen monoxide and see what mom says. See if she knows what it is.
I don't drink that.
Okay?
I don't drink that. Okay.
You know, well, you need to make sure that you get plenty of dihydrogen monoxide.
a trick.
I knew it was water. Colored
Okay?
water.
Yes, it's just colored water. All right, any questions? All right, give me 2 to 3 sentences on what you learned.